All right, the next rung is going to look very similar. It's going to have two inputs and an output. I'm just going to get rid of this down here. It really is not helping us at this point. I'm going to make a copy of this rung. So the quickest way, Control C, Control V, and then click. And I just need to change the symbol on here. So now we're going to, when B extends, B sense 1 is going to go true. And we're going to extend C. So drag the C extend over here. So that completes our forward cycle. Now to go in reverse, it's going to look very similar. So this whole ladder block, I think I'm just going to copy the whole thing and just make some changes. So when C sense 1 goes true, that means it's fully extended. I'm going to do two things. I'm going to tell C to retract, but now I'm going to reset the forward bit. So I have to go back to the ladder blocks, grab the reset output. Whoops, didn't have to click it first. When it turns green, you can drag it over and just click ignore. And then label that with forward. So now C is retracted and we're in the reverse mode. So now we want when forward is false, that means we're going to use one of the examine if open ladder elements. And I'll drag it over here too. So what this is saying is if forward is false, and so we're at the point where C is retracted, if C sensor 0 goes true, then it's time to retract the B actuator. And then once the B sensor 0 goes true, which means the B is retracted, it's time to retract the A actuator. Okay, so we've just made a few changes, and the key was using this forward bit to distinguish between the forward phase of the program and the reverse phase. So let's go back over here and go to Program, Compile, Program Connect, press play, dynamic display, and let's see if it works. So we hit the start button, A extends, B extends, C extends, C retracts, B retracts, A retracts. All right, looks like it works. Now, one thing you might notice, I'm going to just run this again, is the outputs stay on for a lot longer than they really need to. In fact, on the reverse part, the last two retract solenoids just stay powered on. So this is a simulation. It doesn't really make any difference in this environment, but if this were a real PLC, what we're doing here is we're pumping current through a solenoid that's telling a cylinder to retract that's already retracted. So there's no point in keeping power to that solenoid. We only need to provide momentary power to that solenoid to get it to retract. So what we're going to do next is a modification that will make this a more realistic program that takes care of that problem and doesn't have the solenoids sitting there soaking up power for no good reason. So let's turn off the dynamic display. And let's go back to the PowerPoint to talk about how we're going to make this last change. So what we're going to do now is instead of keeping the solenoids on, we're going to have them, let's say for example we tell the A solenoid to extend. As soon as it hits the A1 sensor, we're going to turn that solenoid off, and we're going to do it using the same kind of function we used for the forward bit, which is the set reset function. So for the forward part of the process, we're going to press the start push button, set the forward bit to 1 just like we did before. But this time we're going to extend A, but we're going to set the A output so that it stays true. And then the next statement is going to be the same. If forward is true and sensor A1 is true, at that point we're going to reset the A extend sensor to turn off the solenoid and set the B extend. So each time we're going to turn a solenoid on, we're going to turn the last solenoid off that doesn't have to stay on. And then when sensor B is true, we're going to reset B extend and set C extend. Then for the reverse, when it hits C1 extend sensor, we're going to then reset the extend bit and then set the retract bit for C, and also reset forward to 0. So there's 3 things that have to happen there. Then again, checking if forward is in the forward is 0, we're in reverse mode. Sensor C0 is true. We're going to reset C and then set B. So we keep turning off the actuator before we turn the next one off. Then when it hits sensor B0, reset B and set A to retract. And then at the very end, as soon as A is fully retracted and it hits the A0 sensor, we're going to reset the A retract. So when we're done, there should be no solenoids on. All right, back over to AutoSIM and we'll make the changes. So I'm going to stop this, go to Program, Unconnect. And so what I'm going to do is just basically change this to a set output for the A extend. So let's go to Palette. Oh, sorry, I have to select the ladder diagram in order to bring up the palette with the ladder blocks. Go down to ladder blocks, click on set, and make that into a set, and that will be the A extend. Okay, for the next rung, I'm just going to move this part down, and we will change this to a reset. Whoops. And then we're going to put a set in parallel with it. And then I just got to fill in some of these blocks to make the okay, now go to the symbol list, and then what we're doing is we're resetting the A extend, and we're setting the B extend. And for the next rung, I'm just going to use, I think it's quicker to just copy this because the next rung is going to have the same format. So Control C, Control V, and we're just going to do when the B sensor 1 goes true, we're going to reset B extend, and we're going to set C extend. For the next rung, I'm just going to get rid of this, and I'm going to take this rung and just move it up. And I'm actually going to take this part of this rung and copy it because it has most of what I want to do. So when it hits the C sensor 1, we're going to reset the C extend bit. We're going to set the C retract bit, and there's one more thing we have to do, which is to reset the forward bit. So I've got to add that reset output in parallel, and then put in these blocks to connect it. Let's see, this is going to be and I think I need one more vertical. Extend that down. Okay, and that's going to reset the forward bit. Okay, and I might as well get rid of these because we really don't need those rungs. And I'm going to copy this rung. And so this is going to be now when forward is false, so I have to replace the input here with an examine if open. And then relabel it with forward. And what we're looking for now is for C sense 0 to be true. And at that point, we're going to reset the C retract, and we're going to set the B retract. All right, and then the next rung is going to look very similar. So Control C, Control V. What we're doing here is when B sensor goes to 0, we're going to reset the B retract and set the A retract bit. And then the last rung, I guess I can just copy this. When the A sensor goes 0 goes true, that means the A is fully retracted. We're going to reset the A retract output. Just going to clean up this one little block here with a straight line. Okay, so there's our modified ladder logic using set and reset so that the outputs don't stay on unnecessarily long. So let's see if we did this right. Go to Program, Compile, Program Connect, Play, Dynamic Display. All right, we hit the Start button. A extends, B extends, C extends, C retracts, B retracts, A retracts, and all the outputs are off. Okay, we'll turn off the dynamic display. So just make sure you save the program before moving on.